Hello everyone, welcome back to our IGCSE Math 0580 Extended Revision session. Today we'll be doing Unit 4 Geometry. So first we need to know the geometric terms. This is a point, and this is a line. If the two lines have the same gradient, it is parallel. If the gradient of two lines multiplying together equals -1, it is perpendicular. For a two-dimensional shape, this is the face, this is the vertex, and this is the edge. First, triangles. For a shape to be called triangles, first it needs to be a closed shape, and it needs to have three edges, and only three edges. So if it's a shape like this is not a triangle because it's not closed. And this is a triangle. An equilateral triangle means that the length of its edges are equal, and their interior angles are equal. For a triangle to be isosceles, two of its three edges are equal, and thus these two angles, corresponding angles, are also equal. So if we have a triangle with angle A, B, C, and edges B, C, A, for it to be isosceles, B have to equal to C, and angle C have to equal to angle B. Now a scalene. Scalene triangle is a triangle with three edges, all different. So diff is, for example, 2, 3, 4. This is a scalene. And equilateral or isosceles are not scalenes because they have edges with the equal length. Now a right angle triangle. A right angle triangle means that one of its three interior angles is 90 degrees. There are also acute triangle, which means that the three interior angles are all lesser than 90 degrees. For example, this is a equilateral acute triangle because all the interior angles are smaller than 90 degrees. An obtuse triangle means that one of its angles is greater than 90 degrees, for example 120. Now for the area of a triangle, you'll have a base and its corresponding height, which its height is perpendicular to the base. And the area will be half the base times its height. Now quadrilaterals. Quadrilaterals with the prefix quad means 4, which is a closed shape with 4 edges. For example, a square, a rectangle. So first, square. This is a square. A square has all its 4 sides equal, and all its 4 angles 90 degrees. A rectangle has all its angles 90 degrees, and the sides are in pair. So opposite sides are equal in length. Now a kite. A kite looks like this. Its diagonal is perpendicular to each other, and the kite have adjacent sides with equal length. Now a rhombus. A rhombus is a shape with all 4 of its sides equal, but the angle inside doesn't matter. It could be like this. It could be like this. It's all rhombus. Now a parallelogram. A A parallelogram have its sides in pairs of 2, and the pairs are parallel. For example, this is a parallelogram. Now, because both of the pairs have to be parallel, the pairs which the opposing sides have equal length. For example, this is a parallelogram, and this is also a parallelogram. Or it could be a square, it could be a rectangle. As long as the opposing sides are parallel and have equal length, it is a parallelogram. Now, a trapezium have one pair of parallel sides and doesn't have to be in equal length. For example, this is a isosceles trapezium. This is a right angle trapezium, or it could be like this. As long as one pair of its sides are parallel. Now, to calculate their area for a square, because the four sides are equal, we'll have x and x. The area would be x squared. Now, for a rectangle, they're in pairs, for example, x and y. The area will be xy. Now, for a kite, we need to look at its diagonals. For example, this is x, this is y, and this is z. This is also z. This is because the longer diagonal of a kite is the perpendicular bisector of the shorter diagonal. So you can see this as two triangles. And we have its base 2z, its height y. For the top part, 2z base and x. So the area would be half times 2z times x plus half times 2z times y, which would be zx plus zy. Now for a rhombus. For example, a rhombus looking like this. Because we know that all its four sides are equal, we can just see them as four identical right-angled triangles, with this being one of the sides. So we just have to know the diagonal x and y. We'll get 2xy, because this is half xy, half xy, half xy, half xy, which gives us 2xy. Now a parallelogram. Parallelogram, it will have side x and side y and height h. We can see this just as a rectangle by moving this part here, which makes this a rectangle, which its area is h times x. Now a trapezium. Trapezium looks like this, and we'll have the height, side 1, and side 2. So we can see this as a rectangle and two triangles. But that would be too complicated because we could have a right angle trapezium, we could have a irregular trapezium. So the formula is top plus bottom times height over 2. Now moving on to polygons. Polygons means shape with multi-sides. For example, a pentagon. Pent is 5, which means a shape with 5 sides. A hexagon. Hex is for 6, means a shape with 6 sides. Octagon, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is an irregular octagon. Let me try it again. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is better. Decagon. Dec is 10. So decagon is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for a regular polygon, which means that their interior angle are equal. And Their sides are equal in length. For an irregular polygon, it just needs to have the right amount of sides, and it could look like anything. For example, this have 5 sides, 2, 3, 4, 5. This is an irregular pentagon. To calculate area for regular polygons, the best way is to split it from the center to form triangles, and with the sides and the height either calculated or given, you calculate the area of one section of triangle and times it by the number of sides. Now solid is 3D shapes. For example, a cube is just a 3D square looking like this, with all its edges equal and all its angles 90. So to calculate the volume of a square, we see this as multiple slices of a square stacked together. So the height would be the number of slices, and the base would be width, and length would be just the area of a square. So the volume would be width times length, the area of the square, and the number of the square stacked, the height. Now a cuboid is just a 3D rectangle. So the same, we'll got the base, width, length, and this height. Width, length, height. A prism is a triangle, but a long triangle. So with the same idea of thinking, but now the base is a triangle. So we'll have the area of the triangle times the number, the length, the height. So we'll times the area of the triangle with the number of height, which will have, for example, this is L, this is base B. We'll have B times L times half times height. Gives us the volume of a prism. Now a cylinder. Cylinder, similar to prism, instead it has a base of a circle with given radius r and height h. So we know that the area of a circle is pi r squared. So we'll have pi r squared times h. Now a pyramid. Pyramid, just like the architecture, looks like this. This is a square-based pyramid. A pyramid could be with different numbers of edges of the base, but at last it's made of triangles. So to calculate the volume of a pyramid, we first think it as a square, but instead it lacks of, but we can see that it's lacking some volume. So the volume formula for a pyramid is 1/3 base times height. Now remember, the height isn't the slang here, it's the height to the base, from the top to the base, h. So we'll have 1/3 width times length times height. Now a cone. Cone is similar to a pyramid, but instead its base is a circle. So similar to pyramid, the volume of a cone is 1/3 base times height, which is 1/3, have r, and this is h, r, pi r squared h. Now a sphere. Sphere is a ball with radius r. Now the volume formula for sphere is 4/3 pi r cubed. So as you think of this, this is pi r squared, and one more r, this is the sphere. But only times by r will get a cylinder. But what about the bottom part? And what about the extra volume here? So it's about 1.3 of this kind of cylinder with its base pi r squared. So it's 4/3 pi r cubed. Now a hemisphere. Hemisphere is just half a sphere, looking like this, which is 4/3 times 1/2 pi r cubed, which is 2/3 pi r cubed. Now a frustum. A frustum looks just like a pyramid. This is a pyramid, but with its head chopped. So a frustum will be something like this. Or it could be with more edges, for example, a octagon frustum. 1, 2, 3, 4, like this. Now the area of a frustum is pretty simple. You just calculate the area of its original pyramid and minus the smaller one. Now the volume of a frustum, similar to a pyramid or a cone, is 1/3 its height, which is this height, times its base 1 here, plus base 2, the top one, plus square root base 1 times base 2. Now let's see the last three terms. For example, for a cube, this is a face. All these exposing faces are the surface, and these are edges. The sides are edges. Now the area of its surface area, is calculated by adding the single area of each of the surface together. For example, of a square, its net, which is open its area, is 4 squares. Sorry, this looks like a rectangle, but it's meant to be a square. This is the net of a cube. Net of cube. And all this area here is its surface area. For example, net of a prism. Net of a prism be something like this. 1 triangle, 2 triangle, 3 triangle, 4 triangle, and its square base. And this will be its surface area. Now for a sphere, when it flattens, could be something like this. So when it closes, it would make a sphere. And there's a formula for the surface area of a sphere, which is 4 pi r squared. Now we know that the area of a circle is pi r squared, and the circumference of the circle is 2 pi r. Now move on to geometric construction. So this is where you draw the shape. You need a ruler, a compass, and a protractor. For example, it asks you to draw a square with side length of 4 centimeter. Then you have to measure a 4 centimeter on your ruler. Draw a line, draw a straight line with reference to your ruler, and then take your protractor, measure a 90 degree, then draw another 4 centimeters straight line, a 90 degree, 4 centimeter, 90 degree, 4 centimeter. Now, if you are asked to construct a triangle with given 3 sides, for example, 4 centimeter, 2 centimeter, and 6 centimeter, what you do is you first pick a side, for example, 4, draw a straight line, 4 centimeter, let's say. Then you take your compass, measure the separation of the 2 pins with the length of one of its sides, for example, 2 centimeter. Then you point one end here and draw a chord here. For let's say this is 2 centimeter. Then you do the same thing on the other side. Draw a chord, maybe somewhere here, and let's say this is 6 centimeter. What you do now is use a ruler, connect the point of their intersection with your ends, corresponding ends. Now move on to scale drawing. A question could give you a scale, for example, 100 kilometers to 1 centimeter, and ask you to draw a square with side length, let's say 50 kilometers. What you do, you first calculate by the scale. So this will give us 0.5 centimeter. Then you use your ruler, measure 0.5 centimeter, and draw the square. Or it might ask you, for example, town B printed, point B, and town C. And it would say the map is in the scale of 2 centimeter to 24 kilometers, and ask you the distance between town B and town C, which you will measure the lengths of B and C. Then you'll use the scale to convert it into kilometers. For example, this is 3.6 centimeter. Now what you do, you times the 3.6 by 24 over 2, which will get the answer in kilometers. When you say two shapes are similar, it means that their angles are identical. Sorry, this could never be 90. For example, 30, and this will be 30. For example, 60, and this will be 60, and this will be 90. Well, this is a bad example, but alright. Yeah, it will be something like this, and this will be 90. But the side's length could be different. For example, this is 1 to square root 3. This could be 5, 10, 5 square root 3. So a question could ask, for example, triangle A is similar to triangle B, and A have length 6 centimeter, B have length 36 centimeter, and side A would have a length of 7 centimeter and ask for the length of side B. Now what you do is to find their ratio. The ratio of A to B is 6 to 36. Simplifying this ratio will get 1 to 6. So when A is 7, B will be 6 times of A, which is 42, which is still 1 to 6. So we'll get 42. Now what about areas? For example, we have a square, two similar squares. One have side length 2, one have side length 4. So they're in a ratio of 2. You may say that the area is a ratio of 2, but we can see that 2 times 2, this has an area of 4. And 4 times 4, this has an area of 16. So it's actually 4 times greater. So we can know that the ratio of area is the square of ratio of length. Length ratio squared. And from this, we can derive that 4, this gives us 64. We can derive that the ratio of volume is the cube of ratio of length. And this is inversible, which gives us the ratio of lengths r, equals the cube root of ratio of volume, VR, let's say. For example, you say two cubes are similar. The ratio of their volume is 1 to 27. The bigger cube have a side length of 3 centimeters. Find the side length of the smaller cube. So we know that their volume ratio is 1 to 27, so their length ratio is the cube root of that, which is 1 to 3, because cube root of 27 is 3. Thus, the smaller cube will have a side length of 1 centimeter, 1 to 3. This doesn't just work for cubes, it works for any shape, every shape and every solid. Now symmetry. For symmetry, it means looks the same. For example, line of symmetry. We can see that line of symmetry for this shape is here, because when you reflect, this side with the line of symmetry is equal to this side, the other side. And there's another line of symmetry here, horizontally, because if you reflect about the line of symmetry is the same. Another example could be a triangle, an equilateral triangle. It will have 3 lines of symmetry, 1, 2, and 3, because if you rotate or reflect about any line of symmetry, it will look exactly the same. Line of symmetry could be on any shape. For example, a shape looking like this will have the line of symmetry here. Now, order of rotational symmetry. This means when you rotate it 360 degree, how many times will the shape looking like the original shape? For example, we have a square. If we rotate it 90 degree, it looks like this. If we rotate it 90 degree, it looks like this. If we rotate it 90 degree, it looks just the same. But if we rotate it 45 degree, it looks like this. So a square will have an order of rotational symmetry of 4. A equilateral triangle will have 3, because when it's rotated 120 degree, it looks like this. When a shape only looks like the original shape when it's rotated 360 degree, for example, a trapezium, then it will have a rotational symmetry of 1, order of rotational symmetry of 1. Now, plane of symmetry. Plane of symmetry works for 3D objects, solids. For example, we have a cuboid with square base. Then we'll have a plane of symmetry of 3, because if we slice it in the middle here, it will look exactly the same as the other half. And it also works if we slice it here, or slice it here. So we'll have 3 planes of symmetry. Now, for example, a prism, a, a square-based prism, will have only planes of symmetry of 2, because we can only slice it like this, or like this. Oh, my bad. If it's in square-based, the diagonal is also a plane of symmetry. So it will actually have 4. And this one will actually have 5. And that's it for the first half of Unit 4 Geometry. On the next video, we'll talk about circles and angles. Thank you for watching.